Alright everybody, this is video 11.1.2. We're still working on the standard of simplifying matrix expressions using different operations, and that's what I'm going to show you today. The operations I'm going to show you today are operations we can do by hand. Some of them you need to do by hand because they have variables involved. Others, there is an option of using a calculator, in which we will explore coming up very soon. So let's go ahead and start this video. You shouldn't need a calculator because we're going to just be doing some basic multiplication, addition, and subtraction, but if you want to grab it to feel comfortable, go right ahead. Here we go. Alright, so adding and subtracting matrices together. There's actually only one rule that we have to follow when we add these together, and that is that they must be of the same dimensions. So I have to check first that they are of the same dimensions, and then we can go ahead and proceed by adding the corresponding elements together or subtracting them from each other. So in this case, I have a 2 by 2 plus a 2 by 2. The result of that is going to be another 2 by 2 because each element that's in the first row, first column is going to be added together. So the 2 plus the 9 becomes the 11. Then I have a 7 plus negative 8, a negative 3 plus 0, and a 5 plus negative 1. So the results will be of the same size as well. Here we have a 1 by 3, that is, we have one row and 3 columns, minus another 1 by 3, so my result will be a 1 by 3. So I'm going to write the result down here. Okay, so here we are subtracting. You need to be very careful with the negatives. So I have 11.2 minus a negative 5.6, which means I'm going to be adding them together, making that 16.8. In the next one, I have 4.8 and 2 minus a 2.0, which makes a 2.8. And finally, negative 3.4 minus 1.1. So negative 3.4 minus 1.1 makes that negative 4.5. So the result is the same size as the two matrices we began with. In my third example here, we can see that I have a 1 row by 2 column that I'm trying to add to a 2 row times 1 column, and this is not possible. We're not able to add these together. Alright, next examples. Here we're going to be adding with variables. There really isn't a difference in this except that we're combining like terms more or less. So I'm going to go ahead and do the first one with you, and then I'll give you guys some time to try the second one on your own and reveal the answer. In the first positions, I'm adding the 2 plus x to 4x, so that gives me 5x plus 2. In the second one, I'm adding y plus 3 or 3 plus y. You can write it in either order. In the next piece, I'm adding 2x plus 5 to x minus 1, which makes 3x plus 4. And lastly, y minus 7 and a negative 3 makes y minus 10. I'm not able to solve for any of the variables here because this isn't set equal to anything else. So all we did was combine like terms. If this was being set equal to something else, then I could set those elements equal to each other and possibly solve for the variables. Not the case. Go ahead and try this next one. Be careful, you are working with subtraction. Pause the video, and when you're done, I'll have the answer ready for you. Alright, so this is the answer. I've got for the first row, first column, a 3, then a negative 2m. In the second row, first column, n minus m, and 3n plus 2. If you need to pause the video to check your work or see where you may have made an error, please do so and then proceed to the next problem. Alright, the last part of our video here is going to be involving scalar multiplication. Or the last concept, that is scalar multiplication. You see, the number out front is something we call a scalar. It's a scalar because it's not a matrix, and that's the difference. Is the scalar is going to actually be distributed to the entire matrix. That is, that it will be distributed to every element of the matrix. So that's really what it is it's a giant distribution. It's a way of making one number on the outside get put into everything that's involved in the matrix. It's called scalar multiplication. So let's go ahead and multiply all elements by 3, giving me 12, negative 6, 3.3, and 15. This does not change the size of the matrix because I'm just tripling the elements that are inside the matrix. Let's go ahead and take a look at the next one. This one, the scalar is 1/2. So the results of my scalar multiplication, distributing this on, is 3 and 1/6 and -2. For the last one here, I'm distributing a -2. There just happens to be some variables and algebraic expressions inside. Doesn't change what we're doing here. We're just distributing. So it's a -2x, a -2x minus 2, -4x, and -8. So the dimensions after scalar multiplication are the same as they were when they began. Okay, so here we've got a combination of operations. That is, I've involved scalar multiplication as well as addition, or scalar multiplication and subtraction. So go ahead and try these. I want you to pause and give them a try. Keep in mind that following the order of operations does require you to multiply before you add or subtract. So that scalar multiplication must be done first. When you unpause, I will have both answers available, so make sure you try them both first, and then you can look to see if there were any errors and where you might have made them. Go ahead and pause now. Alright, so the two answers we have, for the first one I've got 10, 14, 28, and -5 as the elements of the resulting matrix. And in the second example I have -3, -9, -12, and 4. Go ahead and check your work, and if you've got this, then I think we're ready. The only other operation that we have not talked about was matrix multiplication, which is very different than scalar multiplication, but we're going to take some time and do that together in class, just because it takes a little bit more hands-on and maybe a little bit more pausing and asking questions. So I really feel that that would be better suited for in class versus these, which are pretty basic. All right, thanks guys.